All right, welcome to week 8 practice problems. We're going to start out with a logarithm problem. It says log base 36 of 6 equals what? All right, so first thing you would probably try to do here is to write the log in exponential form, okay? So we don't know what it's equal to, so I just put in an x here for I don't know what it is. Then I use my spirals to get out of logarithmic form. So 36 to the power of x equals 6. Okay, so 36 to the second power, well, that's not 6, that's bigger than, that's huge actually. 36 to the sixth power, you can see all these numbers can't be right. It's got to be 1/2. And what does 1/2 mean, right? Power over the root means 36 to the first power over the second root, which of course does equal 6. The square root of 36 equals 6. Now, this is a prime candidate for using your calculator, okay? Go back to the calculation mode, and then we've got alpha window, okay, which is where we find our log base. You could also do alpha y equals, and then just scoot over. All you're doing is getting to this function part. Number 5 is log base, so go down to number 5. This allows us to calculate the log of any base. So with base 36 of 6, it's going to give us 1/2. Remember, you can always hit math, enter, enter, and that will convert it into a fraction. Okay? All right. All right, if log a of 3 equals m and log base a of 4 equals n, what is log base a of 36? Okay, so this one seems pretty out there. Like, whoa, where do I even start with this? But look at your answers. See, your answers are a bunch of m's and n's and stuff added and multiplied together. So just think about what you know about logarithms. We're always trying to break these things apart into separate logarithms or put them back together. Well, I'm given one logarithm here. Log base a of 36 equals what? So maybe try to expand that. And notice that they give you log base a of 3 and log base a of 4. That's kind of, why would they give us those numbers? Well, think about 36, right? If we factor 36 down, it's 9 times 4, and 9 is 3 times 3. So you could consider 3 times 3 times 4. Those are the numbers that we were given. So what we're going to do is say that log with a base a of 36 is the same thing as log base a of 3 times 3 times 4. There's our product that we can separate into separate logs. So we say the log base a of 3 plus log base a of 3 plus log base a of 4. And of course, we know what those are, right? The beginning of our problem says that it's log base a of 3 is m, and log base a of 4 is n. So we can make those substitutions. It's m plus n, which simplifies to 2m plus n. So answer choice C is correct. Okay. Now, alternately, I suppose you could have actually calculated what the log base a of 3 would have been on your calculator with any base. So you could be, you could just say, well, what is log of 3? Right, I'm using the base 10 here. It says base a, so it means that the a could be anything. There's log base 3. Okay, log base 4. Excuse me, log of 4 would be this. And then log of 36 would be this. Now, it's hard to tell, but if you add 2 of these 0.47s together, and you add it to one of these 0.60s, you get 1.556. Now, that's hard to tell, but you could look at your answer choices and see which ones wouldn't work. Right? You could try them out. So there's an example of kind of actually coming up with values for m and n, and then seeing which values end up working. All right, which x values correspond to a hole in the graph of f of x equals x to the third minus 6x squared plus 8x divided by x to the third minus x? Okay, so we're asked to find which x value corresponds to a hole. So we're remembering that a hole is when you plug in an x value and you get 0 over 0. So first thing, I got to get a 0 on the bottom. So what values of x make 0 on the bottom? Well, just set up an equation where the bottom is equal to 0 to find out when it's going to be equal to 0. Okay, you factor out an x here. You get x squared minus 1 equals 0. You can actually factor this as a difference of squares, x minus 1 times x plus 1. So we actually get 3 answers. X could be 0, x could be 1, or x could be negative 1. Remember, I just set each of those factors equal to 0 and solve, and I get those opposite signs. So these are my 3 numbers that make the bottom 0. So right now, it can't be D and it can't be E, because those numbers don't make the bottom 0. The question is, which one of those will make the top 0? If I plug in 0 in the top, I get 0 cubed minus 6 times 0 squared plus 8 times 0. I get 0 on the top. And of course, I remember that I had that number made 0 on the bottom. So there will be a hole at 0. Okay. Now, if I test 1 and negative 1, you'll see that you don't get 0. Just plug in 1 for x, you'll see you don't get 0. That means there's an asymptote at those values. Okay. Alternately, this would be, well, I guess I should say that B is my answer. Okay. 0 is the number that makes a 0 on bottom and on top when I plug it in. But this would be an easy one to graph, right? You graph this thing and you would see that at negative 1 and 1, there's vertical asymptotes. And you probably won't see the hole. But let's just go ahead and do this real quick. Okay, so you get x cubed minus 6x squared plus 8x. And on the bottom, we get x cubed minus x. Okay, so if I graph this thing, you'll see 2 vertical asymptotes, right? You see these imaginary vertical lines at negative 1 and 1. And then you'll see that at 0, there's no vertical asymptote, but there's this little hole here, and actually you can kind of see it. I'm surprised that you could see that. Now, if you look at the table, this is an easy thing to see. At negative 1, you'll get an error, 0, you'll get an error, and 1, you'll get an error, but you have to go back to the graph. You see that there's vertical asymptotes here. If you zoom out, it'll be a little more clear. Oh yeah, there's vertical lines at negative 1 and positive 1 that never quite touch, and then there's a hole at 0. Okay. All right, Scott does 2 push-ups on day 1, 6 push-ups on day 2, and 10 push-ups on day 3. If this pattern continues, how many push-ups will he do on day 101? All right, this is definitely a sequence problem. We have on day 1, he does 1 push-up. On day 2, he does, he does 2 push-ups on day 1, 6 on day 2, and on day 3, he does 10. Okay, the question is, what happens on day 101? Okay, we want to know this number here. So this is a sequence. I need to make the general form. So I notice it goes up 4 each time. Okay, that means it's arithmetic. So it's going to be in the form a sub n equals basically your a0 plus your common difference times n. That's basically the formula. You need to know a0 and the common difference. Common difference is 4, so it's going to be 4n. Okay. The question is, what is a0? Well, where does it start? Go back in time, right? What would day 0 be? Well, if we go back in time, we're subtracting 4. So take away 4 from 2, you get negative 2. So this is actually the formula. Negative 2 plus 4 to the n. You can check it, right? When you plug in a 1 here, you get negative 2 plus 4 times 1. 4 times 1 is 4 minus 2, that's 2. See how that matches up with what we have on day 1? What about day 2? Plug in 2. You get 4 times 2. That's 8 minus 2 is 6. You see how that corresponds with what we have on day 2? You can see when you plug in n equals 3, you're going to get 10. It matches the formula. So we've got the right formula. Now we just got to plug in 101. So negative 2 plus 4 times 101 equals what? Well, that's 404. You take away 2 from that, you get 402. And that is the number of push-ups he will do on day 101. Okay. All right, if CD is a coordinate point on the graph, g of x equals x squared divided by x plus 3, then which of the following is true? All right, so just looking at the answers here, I see that it's saying C can't be negative 3, D can't be 0, C can't be 0, C can't be 3, D can't be 3. What is it saying? It's saying the x and y coordinates can't be certain numbers. Okay, so let's think about this. x squared over x plus 3. Is it possible that c, which is really the x coordinate, could the x coordinate not be -3, and why? Well, you'd have -3 squared over -3 plus 3. If I plugged in -3, I would have 9 over 0. You can't divide by 0. So that's it. C is not allowed to be -3 because it's my x coordinate. All right, D cannot be 0. D could be 0. The y coordinate could be 0. If x was 0, you'd have 0 squared over 0 plus 3. You'd get 0 for the y coordinate. That's okay. Basically, this is a rational function, and you should always think, oh, rational functions have certain x values that they're not allowed to be. The y values can be anything they want to be. But the x values, there's certain times when there's domain restrictions, right? Domain is x, and in this case, it says CD is the coordinate, so we're talking about C not being something. So don't worry about the y values, just focus on the x values in a rational function. All right, in a certain geometric sequence, a sub 1 is x plus 1, and a common ratio of x minus 1. Then what is a sub 3? All right, so this is saying that the first term in the sequence is x plus 1, and then the common ratio is x minus 1. So it's like we're multiplying by this x minus 1 each time. So what would a sub 2 be? Well, it'd be x plus 1 times x minus 1. So if we distribute here, get x squared minus x, get plus x minus 1. Middle terms cancel there because they're opposite signs, and I get x squared minus 1. Okay, this is a little out there, but basically you're just understanding what the word common ratio means. It's the number that we're multiplying by each time to get the next term in the sequence. So a3 is just going to be x squared minus 1 times the common ratio, which is x minus 1. So we get x squared times x, which is x to the third, x squared times -1, which is negative x squared, -1 times x is minus x, -1 times -1 is plus 1. So we get x to the third minus x squared minus x plus 1. And that is choice B. So that is the correct answer. Just remember, this problem could be really easily done if it said a1 equals 5, and it said the common ratio was 2. Then you would write, okay, 5 times 2 is 10, times 2 is 20, times 2 is 40. That would be easy, right? Now it gets a little more complicated when there's variables, but don't do it any differently. So if you ever get to a problem that you're like, I don't know how to do this with variables, try doing it with numbers, and then realize that what I did here is the exact same thing that I did here. It just is a little bit more weird or complicated. So don't change the way you do something just because there's something new, like, whoa, I've never seen it with variables. Do it the same way you do it with numbers, okay? Actually, let's go back to that problem now that I think about it. You could let x be anything you wanted to, I suppose. So you could let x be 2, for example. And that would make a1 equal to 3, because you'd have 2 plus 1. If x was 2, you'd have 2 plus 1, so the first term would be 3. Then you're multiplying by 2 minus 1, which is 1. That gives you 3 each time, by 1 times 1 times 1. So when you plug in 1 here, you should get 3. So you could pick a value for x and see which one ends up being correct. That's another way to do that. So pick a number strategy from week 2 would work here as well. All right, solve for x given that log base x of 125 equals 3. All right, so log base x of 125 is equal to 3. We're going to spiral out of logarithmic form into exponential form. X to the power of 3 equals 125. Well, I could do the third root to cancel with the third power here, and that would give me the third root of 125. I could easily figure that out on my calculator. Okay, math down here to third root. The third root of 125 is, well, just think about it. What number times itself 3 times makes 125? It's got to be 5, right? 5 times 5 times 5 is 125. So x would be 5. Pretty easy if you know how to spiral out of logarithmic form. Let's say you didn't. You could guess and check. You could say, what's the log base 3 of 125? What's the log base 5 of 125? What's the log base 25 of 125? You could test all these numbers here into X. Just plug and chug, right? Maybe start with C, or excuse me, start with B. If B is right, then you got it. If B is too big, then you go to A. If it's too small, then you choose D, and then you do that process for week 2 again. But we already figured out it was B. All right, let A equal the matrix 1, 2, negative 3, 7, and B equal the matrix 2, 6, 1, 4. What is 2A minus B? Okay, so remember 2 times a matrix is just basically distributing. So we're going to distribute this 2 into here, and then we're going to subtract B, which is just this matrix here. It's pretty standard stuff here. So 2 times this matrix would make 2, 4, negative 6, and 14. Okay, that's 2 times A. And then when I take away B, I just have to remember, okay, do part by part. So top left minus top left is going to be 0. Okay. Really, from there, I can eliminate choice A and choice C because 0 is not in the top left. Then I do 4 minus 6. That gives me negative 2. That eliminates choice D. Negative 6 minus 1. Negative 6 minus 1 is negative 7. That could be either one choice. Oh, excuse me, it can't be choice B. It's got to be E, but I'll just verify. 14 minus 4 is 10. And yes, certainly enough, it is choice E. Okay? Now remember, you could do this on your calculator as well. That's just a reminder. Go to matrix, which is second inverse. You go over to edit, and you say, okay, this is a 2 by 2 matrix. 2 by 2, boom. And you type in your numbers. So 1, 2, negative 3, and 7. Okay, make sure it looks just like you have it on here. See, 1, 2, negative 3, 7, 1, 2, negative 3, 7. We're good to go. So that's matrix A now. Okay, go back to matrix, go over to edit, and we want to edit matrix B. Make it a 2 by 2 matrix. Fill in the numbers. It's 2, 6, 1, 4. 2, 6, 1, 4. Then you go, okay, I need to do 2A minus B. So quit out of here, back to here, go to matrix. We're going to enter the name, matrix A. I'm going to do times 2. I forgot to do the 2 first, okay? Minus B. Okay, so back to matrix, go to names, hit B, and it will input it in where I need it. There we go. 0, negative 2, negative 7, 10. Just like I got here. I think it's probably a little bit faster to do it by hand, but it's not a bad way to do it by a calculator. So. All right, what is the 25th term in the sequence A sub n equals 12, 10, 8, 6? All right, looking for the 25th term in the sequence. This one actually wouldn't be horrible to do by hand. You could just sit there and subtract 2 each time until you got to the 25th number. But I think this one's still better to do the normal way. Okay, so first off, notice this is an arithmetic sequence. We're subtracting 2 each time. That's my common difference. So I know in my formula, it's A0 plus the common difference times n. Common difference is negative 2, so negative 2 times n. All I got to do is figure out where's my starting point. Remember, this is A1, so A0 would be going back in time. Looks like we're adding 2 if we go back in time. So I would have a 14 here. So this is my sequence, 14 minus 2n. Again, you can check by plugging in n equals 1, you'll get 12. Plug in n equals 2, you'll get 10, n equals 3, 8, n equals 4, you'll get 6. You'll get those terms in the sequence. That's how you can check that you did it correctly. All we got to do now, plug in 25. So negative 2 times 25, that's negative 50. I want to add 14 to that. That's going to be negative 36. There you go, negative 36. All right, if log of x is 3, what is x? All right, this is a logarithm, so usually we're spiraling out. The only thing you have to know is, what is the base here? Log has a base that we do not write because it's the most common base in the world that we use, at least. Log base 10. So when we spiral out, I get 10 to the 3rd power equals x. 10 to the third power is easy. It's 10 times 10 times 10. Right? Use your calculator if you need to, but it's just 1,000. So we get D. Alternately, you could plug in answers into your graphing calculator, right? You could use guess and check here. So the log of what's our first choice, 0.01, that's going to be -2. Okay, log of 10, log of 10. We're just plugging in answers here. Now that gives me 1. I want to get equal to 3. So when you try log of 1,000, it's going to say, oh, that is 3. Okay. Don't be afraid to use your calculator. All right, next question. Find the sum of x and y in the matrix x2 negative y negative 3 times 3 negative 1 0 2 equals the matrix 15 negative 3 6 negative 8. All right, so in this case, they're forcing us to show that we know how matrix multiplication works. So what I'm going to do is I'm going to show you how to do this. You're going to take row 1, which involves an x. Don't mess with doing row times columns that don't give you values of variables. Pick one of the rows or columns with variables to do this process with. So row 1 times column 1 should equal the row 1 column 1 entry. Okay, so x times 3 plus 2 times 0. When you add those two together, that's your thing. You get 15. Okay. The product of the row and the column should equal the row column entry. I did row 1, column 1, so I picked the entry 15, which is in row 1, column 1. Okay, that gives me an equation, 3x equals 15. Well, if I divide both sides by 3, I get that x is equal to 5. Okay, halfway done. Then I'm going to take the second row because it involves this y minus 3, and I could do times the first column or the second column. It doesn't matter. Okay, if I did row 2, which is this, right? Row 2 times column 1, I should get row 2 column 1 entry, which is 6. So row 2, negative y times 3 plus negative 3 times 0 equals 6. So that's negative 3y plus 0 equals 6. So negative 3y equals 6. If I divide by negative 3, I get y equals negative 2. So there's my x and there's my y. Now what does the question ask for? What is the sum of x and y? So 5 plus a negative 2, that means 5 minus 2, right? We got those double signs, we always fix those. Gives me a sum of 3. So I'm going to say answer choice B is correct. Okay? Just remember, they're forcing you here to show you know how the multiplication works. Now this one you can't really guess and check. I mean, because the sum of these numbers is 3, well, that means that x could be 10 and y could be negative 7. Or x could be 100 and y could be, negative 97. So it really forces you to know what you're doing there. All right. So find the general form of the sequence 4, 12, 36, 108. All right, so first of all, you could use guess and check here. You could plug in n equals 1, and you better get 4, the first term in the sequence. You could plug in n equals 2, and you have to get 12. When you plug in n equals 3, you'd have to get 36, and so forth, okay? But really, this is not a difficult sequence to generate. All right, what am I multiplying by? You see how we're not adding the same number each time, right? This is not an arithmetic sequence. This is a geometric sequence. We're multiplying each number by 3 to get the next number. So that means, remember, my geometric sequence is basically your starting point times your common ratio to the power of n. That's our formula. So our ratio is 3, right? So it's going to be 3 to the n. That means I can eliminate choice B and choice A. Well, those are arithmetic sequences, so those are definitely wrong. The question is, what is A0? Remember, this is A1, A2. So what if we went back in time? Notice we're multiplying by 3 each time to get bigger. When we go back in time, we'd be dividing by 3. So what is 4 divided by 3? Well, it's 4/3. So that means that has to be our A0. So 4/3 times 3 to the n. Again, plug in n equals 1, you'll get 4. Plug in n equals 2, you'll get 12. So it will generate the sequence here. So that's another way you can actually make sure you did it correctly. So plug in n equals 1 and 2 and 3 and so forth. All right, natural log of x equals -1, find x. All right, so this is saying that we are looking, we know the base, we just need to know the argument here, the number that we're ended up, the actual power when we do our spiral. But the trick here is realizing this is log base e of x, okay? When you have natural log, it's log base e. It's just a special case. We use it a lot. It's out in nature. It's, you know, in the world a lot. It appears in places. So we give it a special notation. Natural log is log base e. Okay, remember log is log base 10. Natural log is log base e. So if you needed to rewrite it where you saw the base, you could easily do that. Now we spiral out. E to the power of -1 is equal to x. All right, x is just e to the -1. Now I could plug that in my calculator. Okay, e, which is the second natural log here, I could do e to the -1, and it would give me this crazy decimal. Okay, but none of our answers look like that. Okay, so what I need to do is think of it a little differently. Well, it's a negative exponent. Remember how we deal with negative exponents? We put them over 1, make sure we write them as a fraction, and then we're allowed to move things up or down. We just have to change the sign of the exponent. So this would be 1 over, when I move it to the bottom, I get e to the +1 instead of -1. And look at our answer choices. Remember, we wouldn't ever write this +1. We would just simplify that as 1 over e, and that is going to be our answer choice C, 1 over e. Okay. All right. There we go. All right, solve for x. We've got a matrix 2 times xy zw plus x minus y negative z negative w equals matrix 12, 9, 0, -2. All right, we want to solve for x. So we can set up a bunch of different equations here, but really I don't care about the x, or excuse me, I don't care about the y or the z or the w. I only want to make an equation with an x. So I'm going to distribute this to get 2x, right? 2 times the top left is the 2x. So basically what I'm doing here is I'm just rewriting this with only the parts that I care about. Yeah, I could do the rest. I could distribute the 2 and rewrite, but I don't care. I'm only asking for x. So I don't worry about the other parts. Well, this is easy. This is 2x plus x equals 12. 3x equals 12. So x has to be 4. I divide both sides by 3, I get 4. So answer choice E is correct. So again, this one forces you, because it's variables, it forces you to really understand what you're doing. You can't just plug that into your calculator. All right, next one. Rewrite and simplify the expression using positive exponents. All right, so we've got a bunch of negative exponents. We're going to start moving things up and down to get them in the right location. So we've got -2 x to the -3rd, y to the 5th, z to the -1. Got x to the -4th, y to the -2nd, z to the 5th. All right, so I'm going to move everything that's negative. I'm going to move it around here, okay? I'm going to take this x and I'm going to move it up. So I get -2x to the 4th, right? I moved that up there. I'm going to take this y to the -2nd. I'm going to move it up, y to the 2nd. Z to the 5th is going to stay on the bottom. This x I'm going to move down as x to the 3rd. This y is going to stay up top. This z I'm going to move down as z to the 1st, okay? I move my x to the -3rd down, z to the -1 down, x to the -4th up, y to the -2 up. You see it just changes those signs to positive. Then basically I'm going to simplify. I've got 4 x's on top and 3 x's on bottom. 3 cancel with 4 to leave 1 behind, okay? Right here I've got y second times y to the 5th. That actually moves into y to the 7th. I add my exponents together there. Down here, I've got 5th and z to the 1st, z to the 5th, that's z to the 6th. There we go. -2x to the 1st, so I just write x. Y to the 7th over z to the 6th. Notice how I don't move the -2 down? That's -2 to the 1st power. I don't want to mess with that. That's a positive exponent. I leave that where it is, okay? So if I'm looking at all my answer choices, it looks like choice A is correct. Okay. All right, find all the solutions to the equation log base 4 of x plus log base 4 of 4x equals 3. All right, so we've got these log equation here. We need to combine our logs together, and then we're going to spiral out of this. So remember, I can combine two separate logs into one log, just remembering that if they're added together, I multiply the parts. So x times 4x equals 3. Now remember, that just simplifies to be 4x squared. And then here we go. We're going to spiral out of this thing. 4 to the power of 3 equals 4x squared. That's 64 equals 4x squared. Divide by 4 on both sides. You're going to get x squared equals 16. Square root both sides. You get x equals 4 and negative 4. So it looks like choice D would be the correct answer, but it's not. Okay, you got to remember with logarithms, you have to test your answers. So go back to the very beginning. Log base 4 of x plus log base 4 of 4x. When I plug in positive 4, I get log base 4 of positive 4 plus log base 4 of 16. Those are okay because they're positive numbers inside the logarithm. But when I plug in negative 4, okay, for x, I get log base 4 of negative 4. All of a sudden, you cannot do log base 4 of negative 4. It will not work. That means negative 4 is what we call an extraneous solution. It's not really a solution. So negative 4 and positive 4 is not going to be our answer choices. It has to be 4 only. Only 4 will work here. So that's tricky because you're going to work this thing out and go, oh, these are the two answers. But really, you got to use the one that works. Okay? All right, what is the common ratio rounding to the nearest tenth of the sequence a sub n equals 1, 1.4, 1.96, 2.744? All right, common ratio. It's the number that we multiply by each time to get the next number in the sequence. So what number am I multiplying by each time? Well, it's hard to tell back here what I'm multiplying by, but I can definitely tell from the first thing. 1 times 1.4 gives me 1.4. And if you check 1.4 times 1.4 would give you 1.96. And if you multiply that by 1 times 1.4, excuse me, times 1.4, you get 2 points. So my common ratio is that number that I multiply by each time. So I get choice D. All right, find the negative solution to 3 to the 7x equals 9 to the x squared minus 2. All right, if you had no idea how to do this problem, you could definitely plug in numbers and see which ones work, okay? But I think this one's not terribly difficult. It's not an easy problem, for sure. The trick is to rewrite 9 as 3 squared. So this is the same thing. It's 9 to the x squared minus 2. The reason I do that is because I want to get equal bases. Now, how do I do a power to a power? I multiply. So that's really 2x squared minus 4. I distribute that 2 to both of those terms. Okay? That means that I'm going to get equal bases. That means my exponents also must be equal. So here we go. Problem is, this is quadratic. Okay, I could right now graph 7x and graph 2x squared minus 4 and see where they intersect. Or I could use quadratic solving methods. I could do all kinds of stuff, right? Get everything on one side, factor it, set each factor equal to 0. There's tons of ways to do this, right? We know how to solve quadratic equations. I'm going to cheat here, not cheat, but I'm going to use my brain, and I'm going to graph the left and right side. So I'm going to graph 7x, and then I'm also going to graph 2x squared minus 4. Okay, I'm going to graph these two. I'm going to go back to my regular zoom because my zoom is all crazy. There's my 2 intersection points. Now, one is up here, which is a positive 0, right? X is a positive number, which I don't care about because I'm looking for the negative solution. So yeah, there is one over here where X is positive, but I don't care about it. I want to know what this negative one is. First off, it's between 0 and negative 1. So it's probably going to be D or E. Those are the only 2 numbers between 0 and 1. So actually, I'm going to ignore those 3 right there. I'm going to narrow it down to 2. I do second calculate. I'm going to find the intersection, and I'm going to go enter, 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 and it's going to say negative 1/2. Perfect. So D is the correct answer. All right, D is the negative solution to that. Okay. All right, simplify 2 log base 2 of x plus 3 log base 2 of y minus 4 log base 2 of z. All right, this is a standard problem. We've got all these logs, 3 different logs. We want to combine them together. We've got numbers in front, which end up being exponents. We got pluses and minuses, so we're going to have a fraction. We're going to have some division, some multiplication. So here we go. So first thing I would do is I would write 2 log base 2 of x. I would move this up top. So I would call this log base 2 of x squared. Remember that rule? With logarithms, you're allowed to move the number up top to the exponent or move it down out front. It's allowed to move between those 2 things. Plus, and then I would take my 3 log base 2 of y, and I would call that log base 2 of y to the 3rd power. Okay, I'm moving these up into the exponent. Then I have minus 4 log base 2 of z, and I would call this minus log base 2 of z to the 4th. Move that exponent up. That's all we did the first thing. Then we're going to combine our 3 logarithms into 1 logarithm. So remember, it's logarithm base 2 of, and then anything that's a positive. See how that's a positive logarithm? That means it's going to be on the top with multiplication. Here's another positive logarithm. So we're going to have up on top with multiplication. Now we have a negative. So this z to the 4th will go under the division bar as z to the 4th. And that's it. All positives stay up top. All negatives go on bottom of the fraction. They're more like division. All right, so our answer choice is answer choice B. Okay. All right, find the product. A times 2A times, or excuse me, this is a matrix, A times 2A times 3A. All right, find the product of the matrix A, 2A, 3A times 3, negative 1, 0. All right, first thing I want to do is find the size of the resulting matrix. This is a 1 row by 3 column matrix. This is a 3 row by 1 column matrix. So because the middle numbers match, it will be possible to multiply these, and the outside numbers tell me the size. So this is going to be a 1 by 1 matrix. So I can eliminate choices D and E because they're not the right size. So remember how we do this? We pick it up, we rotate it, and we set it on top. So basically this is 3 times A, 3 times A, negative 1 times 2A, and 3A times 0. Now, it's kind of hard to see, but you can kind of tell. That's 3 times A, which is 3A, plus that's negative 1 times 2A, that's a negative 2A, and then 3A times 0 is 0. So 3A minus 2A is A. So remember, you have to stack them, multiply the stacks, and then add up all the stacks together. So you get answer choice C. Okay. Now, I guess you could let A equal a number here. You could let A equal 1, and you would get 1, you get 1, 2, 3 times 3, negative 1, 0. Okay, if A was 1, you would get this. And if you multiplied this, you'd get 3 times 1 plus 2 times negative 1 plus 0 times 3. You would get 1. So if A is 1, here's your 1. That means that's an A. Kind of a creative way to think about that one as well. You could pick a value for A and see which one works. You can even use your calculator then at that point. All right, that's all I got. I appreciate you guys being here, and we will see you next week.